Now, suppose that this angle is a value other than 90 degrees. This relationship is always true for all triangles. If this angle is 90 degrees, then the cosine of 90 degrees is 0. The Pythagorean theorem is actually just a part of this more general equation, which we call the law of cosines. Just as there is a law of cosines, there is also a law of sines. The laws of sines is also always true for all triangles. We have the following 4 relationships. Let us give each of these relationships a name, and we will call them the tangent, the cotangent, the secant, and the cosecant. We started out by saying that theta is the angle from the x-axis in the counterclockwise direction. If we go around the circle more than once, the angle can be greater than 360 degrees. If we go around the circle in the opposite direction, the angle will be negative. We also said that instead of measuring theta in degrees, we can measure theta based on the distance traveled around the circle. The circumference of our circle is pi multiplied by its diameter of 2. If we travel only halfway around the circle, theta is half this value. If we go around the circle in the clockwise direction, theta will be negative. If we go around the circle in the clockwise direction twice, the angle will be negative 2 pi multiplied by 2. We have an x-axis and a y-axis. Let us also create an axis that represents the angle theta. The angle theta can range anywhere between negative infinity and positive infinity. For each value of theta, the x-coordinate represents the cosine of theta, and the y-coordinate represents the sine of theta. The green line rotates by the angle theta. The red line represents the x-coordinate. The blue line represents the y-coordinate. Any function of any shape can be created by adding together sine and cosine waves of different frequencies and amplitudes. By understanding how physical objects respond to sine and cosine waves, we can determine how they will respond to every possible function in the universe.